So today we'll look at just 6 questions, and if you are able to solve any 5 of these 6 questions, then you are actually all set for your exam. That's what I believe. So here is the first question. See, the first question tells us that there is a particle of mass m which has been projected, which means that it has been thrown up with a velocity of KVE. So this is the initial velocity KVE. Okay, this is what it has been thrown up with, and it reaches an height of h, and this all happens on Earth. So this is on the Earth's surface. Earth has a mass of capital M and a radius of r, and our particle here, it has a mass of small m, and we have to determine how high will it go. Of course, the velocity here is less than the escape velocity, so k is less than 1. So we know that the energy of the particle should actually be conserved. So initial energy should be equal to final energy. What is the initial energy? Initial energy is composed of 2 components. One is the initial potential energy, which is because it is above the distance of r from the center of the Earth, so it has some potential energy due to that. And of course, initial energy also is because of the kinetic energy with which it has been thrown up. So initial energy I can write is first the kinetic energy, that is half m v square. V is actually equal to KVE the whole square. That is what it is. And then there is some potential energy. We have already done a class on this, and we know why the potential energy is negative, but that is what the potential energy at the Earth's surface is. Now this should be equal to the final energy, which is simply only because of the potential energy. There is no kinetic energy at that point because the particle has actually lost all its energy, all its velocity, all its kinetic energy is gone. It has been converted to potential energy. So we also know at this point that VE, which is the escape velocity, is nothing but root of 2 gm upon r, where m is the mass of the Earth. Okay, the small m, capital M is the mass of the Earth, r is the radius. So with this I can quickly write k square, and VE square becomes simply 2 gm upon r minus gm m upon r, which is equal to minus g m upon r plus h. Okay, nothing complicated, very simple. We are just simplifying this expression in each step. So m is actually common, so it can go. Similarly, g is actually common, it can go from everywhere. R cannot really be cancelled because here we have r plus h, but this small m can actually also go because this is there. In all terms, 2 and 2 can go. So here what we have is, we'll have 1 by r into k square minus 1 is equal to minus 1 by r plus h. Okay, very simple, nothing complicated. Now we'll just take the inverse of both terms and change this to a positive sign. So this actually will become r into 1 minus k square will be equal to r plus h. In other words, h would be equal to r into 1 minus k square minus 1. Okay, and if you simplify this further, h will come out to be r k squared upon 1 minus k square. Okay, that is the answer. So there will be 4 choices given to you here, of course, but we will be just solving the question ourselves. Now this is the second question. So here we are given a car. Okay, we have been given a car, and we have been told that it starts from rest, and then it accelerates at with an acceleration of 5 meter per second square. Now we have also been told that there is a person in the car who drops a ball at t equal to 4 seconds. Something happens at 4 seconds. Okay, so that is the time that we really have to note here. It is not happening at t equal to 0, but t equal to 4 seconds. Now what happens, what we have been asked is that after the ball has been thrown, at the time equal to 6 seconds, it will have a certain velocity. So we have been asked to find the velocity. So the velocity, as we know, would have both the horizontal and the vertical component, but we have been asked to find the net velocity. And we have been also asked to find the acceleration. See, the acceleration, we can straight away say that the acceleration would only be, the only thing which can create acceleration here is due to gravity. So the only acceleration that this particular car will have will be due to gravity. And of course, acceleration due to gravity we know is 10 meter per second square. So if you notice this much, then you would have been able to solve this question by looking at the choices. But we will be finding the velocity as well, just for the sake of completeness. So here we have a car which is starting from red. So what is the velocity of the car at t equal to 4? So the acceleration is 5. And if I multiply it with the time, then I get the velocity. V is equal to 80. So this is equal to 20 meter per second. And this 20 meter per second is of course in the horizontal direction. Now I also need to find out at t equal to 6 seconds, what is the velocity in the downward direction, okay, or in the vertical direction. And that is of course again equal to, velocity is equal to 80. Acceleration now is equal to, we know that acceleration now is equal to the acceleration due to gravity, which is 10, and then the time here is actually 6 minus 4, which is equal to 2, because the ball has only been traveling for 2 seconds in the vertical direction, okay. So that's why we are taking t equal to 2 here, and this of course again comes out to be 20 meter per second. Okay, notice that after the ball has been thrown out, it has been dispatched from the car, then the acceleration of car no longer affects its velocity. So after 4 seconds, its horizontal velocity will not really change because it will remain constant. It is no longer attached to the car, so it won't get any more accelerated, even though the car might still be accelerating. And of course, the acceleration due to gravity only starts acting at t equal to 4 seconds. It acts till t equal to 6 seconds. So only for 2 seconds this acceleration is acting. So both in vertical and horizontal direction we have the velocity of 20 meter per second. Now if you use Pythagoras theorem, you can straight away say that your net velocity, we'll just say it is v will be equal to under root of 20 square plus 20 square, and this of course comes out to be 20 root 20 meter per second, and that is our answer. So acceleration final at t equal to 6 seconds would be 10 meter per second square, and this would be the velocity 20 root 2. Now with this we move on to our third question. Now here again things are not very complicated. It's actually very direct, very simple question. So we have a wire of length 12a and resistance R. Now see, this resistance R is actually not important in this question because we have to find out this dipole moment in terms of the current I. Okay, so the current I has already been given that we are passing a current I through the coil, and that's what we have been asked. That's what the choices here are given in terms of. So the dipole moment we know is equal to, it is capital M, is equal to AI, okay, A times I. So now current I, we have to find out answer in terms of current I. So the only thing that we really have to worry about is the area. We also have to worry about one more thing, and that is the number of loops. Okay, so if I have an equilateral triangle of side A, then the perimeter of this equilateral triangle is 3A, and the total length of the wire is 12A. So how many such loops of side A, triangular loops of side A can be formed? It is 12A by 3A, and that is equal to 4. So I'll get 4 such loops. Now we know that if the side of a triangle is A, what would be its area? We can simply find it out. 3 by 4 A square, we know that, okay, and that is the dipole moment, only magnetic dipole moment only because of a single turn. But of course this particular coil of equilateral triangle we have actually 4 of these coils, so I have to multiply by 4. So the net dipole moment because of this equilateral triangle would come out to be root 3 A square I. Okay, so that is the first answer. Now what about the square? Again we'll do something similar. A square has side of A, therefore its perimeter will be equal to 4A. So how many coils I can form? It is 12A divided by 4. So we'll just use another color so that we can make this a little more clear. So this is the this color is actually that of the square. So we have here 4a, that is the perimeter of the square, and we have 3 such coils. Now the dipole moment in the case of a square again is area is a square into I, but of course we have 3 such squares, so this will be 3a square I. Okay, not very difficult. Again very simple questions. I mean, you can solve these questions typically in less than 60 seconds, 30 seconds, 40 seconds. Now here this is a little bit of a trick question, you might say, not very complicated, but just a little bit of trick question. So here we have a dipole which is placed in the electric field. Now we don't really know how this electric field is actually changing. We know how this electric field, the direction of this electric field is, but we have been just given that there is an electric field which is emanating from this point. Now at this point right here, we can actually see that this electric field cannot be uniform because it's emanating from a single point. Okay, a uniform electric field would typically be like this. It will all be parallel and made of parallel lines, but of course that is not the case here. So this electric field is emanating from a single point, so this is not a uniform electric field. This electric field is actually, we can say, is produced by a positive charge right here at Q, plus Q, a positive charge placed right here. Something like that can produce such an electric field. Of course there will be more lines of this electric field which have not been drawn, but those are not important either. Something like the positive charge is actually placed here, we can say that. Now this dipole, the positive charge is towards this big Q positive charge, and the negative charge of the dipole is a little further away. So this is closer to our positive charge than the negative charge, which means that the repulsion to this plus Q charge would be more than the attraction faced by this minus Q charge, which essentially means that this dipole will slowly and gradually move in the direction of the electric field. It will move outward. Okay, very simple, not difficult. The only thing is that you have to just understand that by looking at the electric field, what kind of electric field it is. Can it be uniform electric field? I mean, that's where the confusion would actually set in. So here again, very simple question. Okay, see, what we have been told. We have been told that there is a circuit, and this circuit is of course made up of NAND gate and AND gate and an OR gate, and all of those gates are there. And we have been asked that what would be the output if these 3 are actually applied at the inputs. So these are the 3 inputs. These 3 waveforms are applied at the input, and we have been asked what would be the output. Now this is such a simple question. It would be really sad if somebody actually missed this. See, the only thing that you need to know is that this is an OR gate, which means that output to be 1, either of these has to be 1. So if this is 1 or this is 1, okay, this output would be 1. That is all we need to know. Now just look at B and C. When would B and C be 1? When would the output of this NAND gate be 1? This will be 1 if the output here is actually equal to 0, which means that if either of these are 0, if either B or C is 0, then the output here will be 0 and output here will be 1, which means that this output will be 1. So now let's look at B and C. See, when the B is 0, then when the C is high, the B is 0. When the B is high, then C is 0. Okay, so there is no point when these B and C both are actually high. See, only in that case this particular output will become 0. Okay, so this particular output would always remain 1 is what I'm trying to say. Okay, is what we are trying to say, because B and C, when B becomes high, C becomes 0. When C becomes high, C becomes high, B becomes 0. So therefore this output, the output of the B and C gate would always remain 1, which means that this Y would always remain 1, because that's an OR gate. If either of those terminals is of the OR gate is 1, the output of the OR gate has to be 1. So it is very direct question. Okay, and the output here would just be a simple waveform, straight waveform of 5 volt. Okay, very simple. With this we come to our last question. Now, as I said, if you got the previous 5 questions correct, then you are set. If you got 4 of those correct, then we should try to get this correct as well. Okay, so solve with me, try to get this question correct. So here we have a convex lens and there is a point object placed at a distance of 60 centimeters. So this is where it is placed. Now, what we have been asked is that if there is a mirror here at a distance of 40 centimeter from this convex lens, where would the final image be formed? Okay, so very simple. So convex mirror formula is one of the very simple formulas, and that's what it is saying. It is saying that 1 by v minus 1 by u will be equal to 1 by f. Now, if I substitute the values, the light rays are going like this, okay, and the same thing will happen here at the bottom. They will go like this, and then they will converge. Now we are trying to find out at what point they converge, because I already have solved these questions beforehand, so I already know where they will converge, but let us try to find out for you. So we know that 1 by v is what we need to find out. 1 by u is, of course, using the sign convention appropriately, we can say that this is equal to 1 by 30. Now if you solve this comes out to be v is equal to 60 centimeter. So this is from 60 centimeter from this mirror in the forward direction, our image is formed. So it is formed right here at a distance of 20 centimeter. So from the lens 60 centimeter, 20 centimeter from the mirror. Inside the mirror, the image is formed, which means that it is just virtual image. So what does it mean? It means that the light rays would actually just come here, they would get reflected, and then they would actually meet somewhere here. Similarly, the light rays would come here, they would get reflected, and they would meet somewhere here. This is what it means, and they would virtually meet here. What about the object? See, for this image to be formed, the object, the real object, would be here at 20 centimeter in front of the mirror. Okay, so 20 centimeter in front of the mirror. So this is 20 centimeter. Okay, so now that is clear. We already know that this is 20 centimeters. So what to do now? Now we have to find out, is there a second image formed because of this the real object at 20 centimeters? So would this mirror now form another image because of this object, okay, which has been projected because of the mirror, because of this mirror? So let's see where the image of due to this object, okay, this object right here, would be formed because of this lens, the convex lens. Again, we use the same formula, will not do anything tricky. So this is 1 by v, and of course again using the sign conventions appropriately, we can say that this is this, and if you solve this v will come out to be minus 60. What does it mean? It means that from the mirror, okay, from the mirror there would be another image which would be formed, and that would be at a distance of 60 centimeter like this. Okay, see, for the second formula, we have to understand the direction of light rays is now opposite to what it was here. Okay, so now previously we were working with this direction of light rays. When we were solving this object, we are working with the light rays which are coming from this object in this direction. Okay, so that is why this minus 60, we go 60 centimeters this way, and 60 centimeters this way again takes us to the same point where our first image was actually formed. So final answer would of course be 20 centimeter. Okay, so it would be 20 centimeter inside the mirror. That would be the final answer. So very simple questions these were. Okay, hopefully you were all able to score at least 5 of these questions correctly, and then we are all set. Thank you.